Parrot Industries has $100,000 to invest. The company is trying to decide between two alternative uses of the funds, which are shown below. The working capital needed for Project B will be released at the end of 6 years for investment elsewhere. Parrot Industries' discount rate is 14%. Ignoring income taxes, use the net present value criteria to evaluate the investment alternatives. Again, we're going to look at both Projects A and Project B using our factors from our present value interest factor tables and using our financial calculators. Let's begin by looking at Project A. The present value of the initial cash outflow of $100,000 at time 0 will be discounted at a factor of 1.0. In other words, it won't be discounted at all. So its present value is $100,000. The annual cash inflows of $21,000 per year need to be discounted at a factor of 3.889. This is our present value annuity factor for 14% interest and 6 periods or 6 years. We multiply the 21,000 times our 3.889 factor and we get a present value of our cash inflows of $81,669. The salvage value is a lump sum cash flow of $8,000 at the end of year 6. We need to discount that back at a factor of 0.456. This is simply a present value factor of a lump sum at 14% for 6 years. So multiplying the 8,000 by 0.456, we get a present value of $3,648. Adding together all of our present values, or taking our present value of our cash inflows minus our initial cost, we get a net present value for Project A of negative $14,683. This isn't a good project. Let's go ahead and calculate the present values using our financial calculators. Again, the time 0 cash flow of $100,000 has a present value of negative $100,000. The annual cash inflows have a present value using your financial calculator of $81,662. In your financial calculator, we'll enter N for number of periods will be 6. Our interest rate is 14. The annuity payment is $21,000 per year. And we enter 0 for our future value and solve for the present value. And we get $81,662. For the lump sum or salvage value we get at the end of year 6, we'll enter again 6 for the number of periods, 14 for our interest rate, 0 for our payment, 8,000 for the future value, and solve for the present value, and we get $3,645. Again, there's a difference between these numbers and the amounts we get for our table calculations because the tables have rounded numbers. The net present value then for our project using our financial calculator is negative $14,693. For Project B, the working capital investment of $100,000 at time 0 doesn't get discounted at all, so it has a present value of negative $100,000. The annual cash flows of $16,000 a year are an annuity cash flow and will be discounted at a present value annuity factor of 3.889. That's our present value annuity factor at 14% interest and 6 years. Multiplying the two together, we get a present value of our $16,000 a year annuity for 6 years of $62,224. At the end of the project, our working capital will be released, or we will get it back, and we'll have a lump sum cash inflow of $100,000. To find the present value, we go to our present value factor table for a lump sum at 6 years and 14%, and the factor is 0.456. Multiplying this by the cash flow, we get a present value of $45,600. And again, the net present value is simply the present value of the cash inflows minus the initial project cost, and we have a net present value of $7,824. Using our financial calculators, the working capital investment at time 0 has a present value of a negative $100,000. The annual cash flows has a present value of $62,219. We'll enter 6 for the number of periods, 14 for our interest rate, The payment or our annuity field will be $16,000 a year, and we'll enter 0 for our future value. And we'll solve for our present value and get $62,219. The working capital that's released at the end of the period will enter 6 for the number of periods, 14% for our interest rate, 0 for the payment, $100,000 for the future value. And if we solve for the present value, we will get $45,559.